In New York, on an unusually chilly day on December 9th, 1906, a cute little baby girl was born to parents Walter and Mary. It quickly became obvious that their daughter was especially curious. At age 7, her mother noticed that 7 alarm clocks in the house had been disassembled. Her mom then put a firm limit down for young Grace Murray that she could only have a single clock. Due to her low Latin scores, Grace was rejected from Vassar College at age 16, but was admitted the next year. She graduated with honors in 1928 with a degree in mathematics and physics. She then went on to earn her master's degree at Yale in 1930. In 1930, she also got married to Vincent Hopper, and even though they divorced in 1945, she retained his surname for the rest of her life. In 1934, Mrs. Hopper earned a Ph.D. in mathematics from Yale. When World War II started, Grace tried to join the Navy, but again faced rejection as they said her job in mathematics was too important. She was too old at the ancient age of 34 and was below the Navy's weight minimum of 120 pounds. After overcoming these obstacles, she was eventually accepted in the Navy Reserve Waves program. Again, she graduated at the top of her training class and went to work at Harvard on the Mark I computer. When the war ended, she tried to join the regular Navy, but was again turned down to her advanced age of 38. In 1949, she then went to work with a team developing UNIVAC 1, which became the first large-scale electronic computer to be on the market in 1951. It was while working on the UNIVAC project that she began to champion the ideas of interacting with computers using English words and not simply symbolic language. She felt that would allow a more natural interface, as well as accomplishing more in the same amount of time. Again, she faced pushback, but continued her work and eventually created the world's first compiler, a program to write programs that is still a concept used in computers today. As her work developed, she worked on a few different coding languages, and after completing a linker, which was another crucial step toward making computers easy to develop for, she helped create COBOL, which is a rich data manipulation program that is still in use today. As her amazing career continued, she served as the director of Navy Programming Languages Group in the Navy's Office of Information Systems Planning and got promoted to the rank of captain in 1973. In the 1970s, she also worked to decentralize the big systems and replace them with networks of smaller distributed systems so that users on any computer could access common data pools. In essence, she helped make the concept of the internet a functioning reality. Near the end of her career, she was promoted to the rank of Commodore by Ronald Reagan. She stayed on active duty several years after her mandatory retirement age by special approval of Congress. She finally retired from the Navy in 1986 as the oldest serving member at the time, and was awarded the Defense Distinguished Service Medal aboard the U.S. Constitution. You know you're somebody when they bring a warship to your retirement party. Grace wasn't done yet, though. After retiring from the Navy, she then went on to work for DEC and acted mostly as a goodwill ambassador and represented the company at events and giving lectures. She continued working until her unfortunate passing to natural causes at age 85. As a person, she was just as remarkable as her professional accomplishments. She has been described as blunt but witty. She was very personable and worked well within the teams she was involved with. Her "don't tell me I can't" attitude was always tempered with bringing people along with her, gaining knowledge and understanding. When she spoke of her most important accomplishments, she said, quote, "Other than creating a compiler, it was sharing this knowledge with young people and stir them up at intervals to make sure they don't forget to take chances," end quote. Grace Hopper's contributions to modern computer science cannot be understated. She worked boldly to build a bridge between the computer's capabilities and the human factor to harness those capabilities. Her development of the systems to talk to computers in languages that we can understand opened the door to allow practical productivity to skyrocket on the systems used. She laid the groundwork for modern AI by giving us the tools to ask questions and get responses that inherently made sense and were useful. I think if she were alive today, she'd be very pleased with the progress we've achieved in areas like large language models and speech recognition. As the recipient of 40 honorary degrees during her life, she was one of the most recognized pioneers in the frontiers of computer and their usage. In 2024, the tech giant NVIDIA named both a CPU and GPU architecture in her honor. She even has a guided missile destroyer named after her. Now that says something. Grace's legacy continues to be part of every aspect of computer language and compilers. She has helped make a mark on all of our lives, and I think we should be very grateful for her service. Another of Grace's accolades was she showed us that overcoming obstacles is the key to progress. In her life, she faced many stereotypes and setbacks, but didn't let that bring her down. She demonstrated that perseverance and hard work can be rewarded with success when it seems very unlikely at the start. She serves as an inspiration to us all to keep plugging and don't accept the difficulty of a situation as ultimate defeat. Godspeed, Grace. Well done and thank you.